So, hi and welcome to my talk, diving into JumpServer, the public key unlocking your whole network. I want to talk to you today about a research project of mine that I worked on last year and some vulnerabilities I discovered in the open source bastion host software JumpServer. First, a little bit about me. I'm Oskar. Hi, everyone. I'm a cybersecurity student in Bochum, Germany. Also a CTF player at the Fluxfingers team there. Maybe you know it. And also a vulnerability researcher in Sona's R&D team. So the R&D team basically drives product innovation through discovering new zero days. We're a young team of about 3.5 vulnerability researchers. Sorry. You can guess who the 0.5 is in this equation. And we discovered already more than 200 findings. And also for this Insomnia hack, we present 2 talks. So please go to the talk Beating Sanitizers with Mutation-Based XSS tomorrow from my colleagues over there. But you want to know what's going on in this talk. So first I want to talk to you about why this thing that we're looking at is actually interesting, why attackers find this interesting, what this actually is. Okay, what is JumpServer? And then we're getting straight into some bugs, so some authentication bypasses. We'll take a detour through the SSH authentication protocol. And after getting authenticated, we will find 3 different ways to gain remote code execution and take over basically everything. And of course, wrap up at the end. So imagine you have a network with some servers in it and you want to protect them. So you maybe have the idea, okay, I'm building basically in an abstract way a security boundary, and you put a access point, like a server where users can cross into the security boundary. You put it at the beginning. And this is, of course, very easy to do. You have a single point where you have to manage access. You can do some logging there. It's very easy to implement. But this also means this is like a single point where if an attacker compromises it, they can compromise everything inside the boundary, because inside no more further checks are performed. And there's, of course, lots of these things happening in practice. So you can imagine like VPN devices for classical LAN setups, or single sign-on for cloud-native companies, Active Directory for basically every company ever. So if you hack those, you get everything. And another one, the thing that I want to talk about today, is a bastion host. So a bastion host is software where you can basically tunnel your SSH connection inside an internal network. And it has all the characteristics. You can centralize authentication and logging, but also if somebody compromises this thing, they get access to everything inside the network. And so JumpServer, the thing that we talk about today, is such an open source bastion host developed by the company Fit2Cloud, a Chinese company, so it's predominantly used in China, this software. And they not only offer SSH tunneling, but basically everything. So they have RDP, HTTP, databases, FTP, everything. You can do it through JumpServer, and it provides really a single point of access. And everything packaged in a nice web terminal. So users who want to connect to some server, they can just connect via web terminal, or they can choose to connect via SSH and get a nice menu in their terminal. Administrators can log everything, have the administration at a single point. Pretty cool stuff. So how is it actually built? So we have a user on the left here. We have some servers and databases on the right. And JumpServer sits in the middle, but is actually made up of microservices, or concretely some Docker containers. And so you have all the classics like a web proxy, you have a database, you have a API of some sort, but also stuff that is specific to JumpServer. And these are not all the things that we talk about today. They have even more containers with some interesting names. I was first wondering, what are they doing here? It turns out they're using names from Dota 2 characters. So maybe you recognize some of these. And also the guy on the right, we will see him throughout this presentation, because it's the name giver of one of the containers here. So going through these, we have a main API. It's like a Python Django server, classic thing. All the authentication authorization is happening here. And also this thing has access to the database containers, so it can check the authentication details of the users and stuff like that. In the database, all this stuff is stored. So you have username, password hashes, or SSH public keys, which are authorized if people want to use SSH to authenticate to JumpServer. But also it stores credentials for all hosts in the internal network. So you store SSH private keys in there, database passwords and stuff like that. So the JumpServer can connect to these internal services and proxy everything for the user. So very juicy information in here. Then we have the Cocoa container. This is where all the tunneling happens. So this is a Go binary which implements the web terminal. So you can use SSH or like database protocols over the web. It also implements like a web file explorer. So you have a nicer view on the FTP files. And the SSH tunneling if you directly connect via SSH and not via web, also here. And then we have the Celery container, which is named after the Python library Celery, which is a task queue. So this thing has like can be used to run like recurring jobs, like connectivity tests, or you can use it to run custom jobs, which we will also talk about later on. All of this stuff is interconnected, obviously, and these are too many arrows for any of you to remember, but we will only talk about some of them and zoom in into detail. For an attacker, it's really relevant to look at these here because the web container as well as Cocoa are exposed to the outside, or that's at least how it's recommended. And so an attacker may try to contact these services first to see what they can do. And I think that's what we want to do now. So let's look into some ways to bypass authentication in JumpServer. So getting authenticated, you can do it via the web UI. Yeah, of course, username, password. You can do the same thing via SSH. And then when you're logged in, you can see all the stuff that you have access to. You can also, like either in the web UI, but also as a terminal thing. And you can imagine like via HTTP, this is like a pretty simple setup. You just do a post request to some API endpoint with your username, password to the web container. It gets forwarded to the main API, which will check in the database if your credentials are correct. And if they are, you get a login token, a session token of some sort, and you can do stuff with it. I mean, everybody has probably seen something like this, but via SSH, they do it a little bit differently because, I mean, how do you have session tokens via SSH? You don't really have it. So what they do instead is user connects to the Cocoa container with username, password, and the Cocoa container will do the login API request instead. So it will request to the core API, say, hey, if this username and password, is it correct? And if so, it gets a session token back. Now this session token is stored inside the Cocoa container and it will hold onto it. And so later on, when I as a user want to do something in JumpServer, it will just associate the session token with the current SSH session and can proxy basically these requests for me to the main API. So like, hey, okay, what's your name? And I get it back over the SSH session. Of course, we all know you shouldn't do SSH with passwords. You should use public keys. So how does that look like? So here basically I have a user who asks, hey, I want to log in with this public key. Is it okay? And Cocoa doesn't know if this public key is okay because everything is stored in the database. So it also asks the main API, hey, this user admin wants to log in with this SSH public key. Is it okay? And then after it is checked, it also gets the session token back. And if it can tell now the user, okay, this public key was correct, and afterwards the user can actually verify that they own the private key corresponding to this public key, and if that works, they are logged in, and the same scenario happens as before. So what can we do here as an attacker? Maybe some of you already noticed. As an attacker, we might think, okay, SSH authentication is usually pretty secure. Let's just not talk to Cocoa at all, but instead talk to the web container. And we will just try sending a login request with the username, but not a password, but the SSH public key. Mind you, the attacker doesn't know the private key, but I mean, why would they? We just try and see if it works anyway. Okay, here we go. And if it works, they also get a session token back. And mind you, this attacker never verified that they owned the private key actually. Yeah? So they just sent the public key and got a session token back. Pretty easy stuff. And I mean, I don't really have to tell you that SSH public keys are not secrets. They have public right in the name. They can easily be scraped from GitHub, for example. And I think this is something that we should check out right now. So let me just switch over. So here on the left, we have my personal GitHub account. And if on the right, I have some scripts that automate talking to the API. And if I just attach .keys to the URL of my profile, I get this page. And it just shows my public keys that I have authorized for my GitHub account. It's okay, they are public. That's right in the name, so it's no real big deal to publish them here, but for JumpServer it actually is. So if I just copy them over into my script here, it turns out I just get an API token back, and I can use that to impersonate this user and get these, for example, the servers that this user has access to. And yeah, we can also try that for another user, maybe this guy here. And we can also see, okay, he also has some keys. And for him, it turns out, we get an error message saying MFA required, multi-factor authentication required. Okay. So it turns out, if you want to be extra secure, you can enable multi-factor authentication with JumpServer. So probably all know this, like, okay, I scan a code, I enter my 6 digits from my phone, and then I'm logged in a more secure way. And you do this via web all the time, but how does it actually work with SSH? Pretty weird. I mean, usually you'd never get this prompt when you're logging with SSH, right? So to check this out, we have to zoom in a bit. What are they doing here exactly in this container? It turns out they use a library to implement the SSH server functionality. So this library, I checked through all of the code, basically. I searched far and wide, and I found no mention of multi-factor authentication. Instead, it turns out they forked this library and made some changes to it to add the capability for multi-factor authentication. And maybe some bugs also went in there as well while doing this. And to understand these bugs, we have to now get into the SSH authentication protocol to actually understand how these work. So, the SSH authentication protocol, this is something that I don't know if a lot of people know how it exactly works. I mean, everybody probably knows SSH is something where I can connect to a server, it's encrypted, I can authenticate, I get a shell. But the authentication thing is happening right in the middle, so after the encryption, but before actually getting a shell connection or something else. And how it works in a nutshell is that the server has a list of authentication methods, and these methods are then sent to the client. The client can ask for this list of authentication methods and chooses any of the supported ones. And the ones that are standardized are public key, password, host-based, and keyboard interactive. And we will check out some of them here. So, for example, if I have this user here who wants to connect to a server, he first tries to connect with tries to authenticate as the user admin and tries to use the authentication method none. And of course that fails. I mean, you can't authenticate with nothing, but it turns out this actually serves a purpose. So the client uses this to actually ask for the list of available authentication methods from the server, because with every failure message, the server replies with the list of available methods. So this is basically like a roundabout way to say, please give me the list by requesting the non-authentication method. So now the user knows, hey, the server supports public key and password. So let's just use public key, for example. So I'm requesting, I want to log in as admin, and I want to use this public key. Mind you, the private key has no role in this yet, because the user probably has multiple public keys and private keys lying around. They don't know which one is the correct one for this server, so they just try every one. So they send the public key only, and the server now has to decide, is this key authorized for this user or not? So usually you check in some file where it's stored, and then the server can respond saying, okay, public key, okay, for example, or with another failure message if it is not authorized. And finally, if it's actually authorized, the user can sign the same message. So they send the same message again, but with a signature attached. And the signature now says, okay, I actually own the private key. The server can verify it. And if it's okay, they get a success message, and now everything works and they can log in and use a shell or something else. This is the setup for like a usual SSH server, and for JumpServer it's a little bit different, because it doesn't check in a list of doesn't check in a file the list of authorized keys or something. Instead, because it's a library approach they use here, they have callback functions where you can implement whatever logic they want to check if a password or public key is correct. And they do this, for example, for public key to check with the API, hey, is this public key the authorized for this user or not? How does multi-method, multi-factor authentication come into this? So it is actually a thing that is possible in SSH. It's standardized in the RFC and everything. You can do this by specifying an extra flag in a failure message called partial success. So if you set that one to true, you tell the client, hey, your authentication was correct, but you still need to do more. And only then are you actually authenticated. And in this message, then you advertise the remaining authentication methods. And so now the client knows which one to choose next. JumpServer adds this functionality in the library fork because originally in the normal Go library, it wasn't there. And then they use the keyboard interactive method to implement this multi-factor authentication prompt to ask the user for their TOTP code. How does that look like? It starts like the similar thing. We have the user who wants to use, again, username and password via SSH. They connect to the Coco container, and then the container will check with the main API if these credentials are correct. But instead of getting a session token back, they get a partially authenticated session token, which also with the error message that MFA is required. And now they can relay this back to the user via SSH and say, hey, this didn't work, but instead we set partial success to true, so you should try keyboard interactive next to fully authenticate. And yeah, they of course do that. You can use now the info request message to put an arbitrary string here, which will be displayed as a prompt to the user in the terminal. They can enter their code. And now the Coco container has to check again, is this the correct code? Because everything is going through this main API. And if it's the correct one, we successfully authenticate it again. For public keys, it's looking almost the same. Here I'm skipping ahead a bit. So we see this message is already signed. So this is like the last step in the public key authentication flow. And now, after checking the signature, of course, the core API is again asked, hey, is this key correct? And if so, the same thing basically plays out again. Yeah, so we've already seen this. But this also begs the question, what can an attacker do with the public key and not the private key? Remember, we can just download it from GitHub somewhere and hopefully it was reused. And let's see. So what an attacker can now do, if they still want to send accepted SSH authentication protocol messages, they can just ask, hey, is this public key correct? And then, of course, Coco has to check with the main API. The main API returns no. You have to do a multi-factor authentication. And this confuses the state of Coco a bit. And it turns out it just replies with this failure message again in exactly the same way we've seen before, also saying partial success true. So what this means, basically, we've successfully done the first authentication and without actually ever having the private key. And now we can try to brute force the TOTP code that is correct in this case. So we skipped one of the two factors of authentication here. It turns out this vulnerability, it wasn't discovered by me. It was discovered originally by Ethan Yang, Huisong, and PokerStar XY. So from the screenshots and the advisory, it looked a bit like they'd have discovered this by accident. I don't know. I didn't ask them, but it looks like it. Because you can see here that they just used SSH to, like the normal SSH client, to connect to their server with only a public key. You can see it. They only used these test.pub file and were immediately asked for a TOTP code without ever having the private key stored on this computer. And after this vulnerability was patched, now they get an error message. What happens here is that the OpenSSH client tries to load the private key that is now necessary to verify, to create the signature. They try to load it from this file, and of course it isn't there, and now the thing fails, and it seems like everything is fine. And I thought, okay, this is so weird. Like you're skipping authentication in SSH. This is something you think, okay, it's a super secure thing. It exists forever. So I really investigated this, and I also wanted to investigate, okay, well, how did they fix this actually? And it turns out they just fixed the thing here with the message. So now it says, hey, public key is, this public key is okay. Now you should verify. And of course, my OpenSSH client, my normal one, they would now try to verify that they have the private key, but they don't have it. So everything fails. But of course, an attacker doesn't need to actually use a compliant SSH client. They can just code their own one and still ask, hey, can I still use Keyboard Interactive, please? And still enter the code, and the server says, yeah, of course. I mean, my internal state says multi-factor authentication is required, so why not just do it? So here the bug really lied in the state machine, basically, that this Coco container had. And the patch, the first patch at least, only patched the messaging behavior, but not really how they are tracking in which state the session is in. So you can still try the same thing, like try the brute force code. But it turns out I wasn't entirely honest, because you can't really do that, because at some point we get a rate limiting error and the SSH connection fails and closes. So I hope you enjoyed this journey through SSH authentication. But unfortunately, we can't really use this bug in a full exploit chain, but I think it was still really valuable. And we can look at the rate limiting next, of course. So, I mean, how do you do rate limiting? You, of course, check the IP of the user, right? So this user here sends a lot of messages with this IP, and so we should block them. But of course, everything is centralized in this core API, and Coco doesn't really do the rate limiting as well. So what they do instead, they just forward it using this extra parameter in the JSON body here, remote address. And then at some point, the core API, after counting how much failed attempts this IP has made, can say throw in rate limiting error and the connection is closed. And if we really look at this, it looks very similar to the thing that we have seen before, right? So with the SSH public key for logging in, because this is just like some parameter in an API call. So let's just do the same thing again. We put the remote address here in the body, and we just write some random values in there. And of course, at the end, if you do this for long enough, you eventually brute force the MFA code and get the token. It of course takes like 2 hours or something. Like statistically, it's a bit hard, but it can work. As a small bonus, you can also use X-forwarded for. Or you can like brute force passwords or anything you want, really, because all the brute force protection is hinging on this one thing, right? So you can just throw your rockU.txt in there or something. So, okay, we've now seen multiple ways to bypass authentication. So if the user uses as an SSH public key, you can just log in with that. If they use a password instead, you can try to brute force it by bypassing the rate limit. If they have TOTP enabled, you can do the same thing, basically. And if you fixed all the bugs we've talked about, there's, of course, more, because there's some password reset code that is also not rate limited at all. You can just brute force it forever. Or there's also a really interesting thing where you can fixate the password reset code because there's an insecure random number generator. But this one was not discovered by me, but by Xinyan Peng and Lauliet from Sangfor. You should check out their blog. And so a lot of possibilities for us as an attacker. But if you want to understand why all these, or at least some of these vulnerabilities occurred, we can zoom in on some of these that we talked about, and we notice, okay, there's a common pattern here. This is really a problem of checking authentication, right? So there's some privileged functionality that this one microservice, namely the Coco container, is getting, namely that they can authenticate using only an SSH public key, and you already get the token from that, where the security of SSH is hinging on checking the private key. Or that they can configure the IP directly in the body or in the header or something. So this is something that is really reserved for the Coco container. But there were no authentication checks to check if it is really coming from them or from an attacker from the outside. And so what you should really remember here is that not only the humans on the outside are users of your API, where you have to check authentication, but also the microservice itself in your microservice architecture. Okay, let's take a quick breath, literally. Because we're now authenticated, and we will now see how this leads to RCE in 3 different ways. Because an attacker who has a user account, they can use that to connect to some hosts that this user account has access to. For example, these 2 over here, and they can try to use that initial access to maybe find more stuff. So maybe they do an nmap scan or something and try to find even more things inside the network from their current position. But of course, there are probably more servers that they don't have access to because they are hidden behind some other user account. And there's also logging like everywhere. So if somebody actually checks the logs, they will discover that something is up and the attacker gets booted out. So they really want remote code execution on JumpServer to bypass these additional hurdles and get additional access. And luckily, having a user account unlocks a lot of new functionality that we can look at. So for example, we've seen this web terminal a lot of times, but not only you can use that one. You can also use this other thing that's looking slightly like a web terminal. There you can also just put any shell command in there. You can run it on a host that you have access to. So for example, if I have access to like prod1 in this case, I can run the ID command and it turns out this runs now on this remote server and I see the output on the bottom. So wondering like how do they achieve this? How does this work? Is this just like normal SSH tunneling or not? We can just Google around a bit and it turns out this is actually using Ansible. I didn't know also what this is before, so I just Googled and it turns out Ansible is an open source IT automation engine made by Red Hat. And what this actually means is that you can use it to write scripts inside of YAML files and execute them over SSH on a fleet of hosts that you have access to. So this is something that usually IT administrators or network administrators use to configure their servers in bulk and have like a nicer way to do it than just having random scripts lying around. And this is integrated directly into JumpServer. So you can just write your YAML file directly inside of the web UI. And so this task that we see here will now run on all hosts that the current user has access to. And then we get the output in a pop-up window, and there we can see everything that happened by running this task. And now the question becomes, how is this implemented again? Like which container is responsible? Because now we're looking at a different one. We see this user here that wants to run a job. They send it via the web proxy directly to core. And this will now go to the salary container and says, hey, I want to schedule this job here. And at some later point, the task queue decides now it's time for this job because maybe it doesn't happen instantly. It has a lot of other tasks to do first. And then at some point it decides to do it and takes the playbook, gives it to Ansible, which is integrated in the salary container as a library, and uses SSH to connect to one of the servers and run the command. And then it inserts all the logs inside the database. And so for all of this to happen, this means that the salary container also has access to the database because it uses it to pull the private keys and passwords and whatnot to execute all of this stuff out of the database and also inserting the logs into the database. So again, interesting target. And at some later point, I can get the logs back and see what actually happened there. So I want to give you like a rundown of one-to-one my exploration that I did like 1 month ago when I prepared these slides. I wanted to make some screenshots and I saw, okay, I never seen this Ansible stuff before. So let's quickly take a look. So I just clicked on this question mark because I don't know anything, right? What this feature does. So I get a nice pop-up and I see, okay, apparently you can use some variables inside of Ansible playbooks here in JumpServer. Okay, but I also see there are some curly braces all over there. So this feels like you maybe have some templates that we can use here inside of this YAML. And it turns out it's true. Ansible by default has templating using the Jinja 2 template engine integrated. And it will evaluate all template expressions inside curly braces in your YAML file. But the question now becomes, does it also mean there's template injection, which means running arbitrary Python code? And we can just quickly check by copy-pasting a payload in there in one of these YAML files, and it turns out, yes, it works. And now what this means is that this is running on the salary container and not the host where it is expected that is to run. And of course, also as root, because why not? So now we see here how this looks like in the nice overview. So I as an attacker, I have already an account. I have access to, I don't know, any host, or it doesn't even need to be anyone. And I'm posting a job with my server-side template injection payload in there. And this will compromise the salary container directly. And with that, I can just go to the database, pull out all the credentials in there, and log into all hosts that are inside the internal network and do anything I want. And of course, like delete the logs afterwards that I was ever there. I mean, that's already pretty cool, but of course it's not the only thing, because there are actually more insecure Ansible features, who would have guessed. And it turns out not only can we use templates, but we can also run tasks on the local system. So what this basically means is that maybe I, as a network administrator, want to first like move some files on my own system around, read something from them, and use that in the tasks that follow up in the execution. So it's a useful feature, and that's why Ansible has it. And so when we specify this hosts keyword here and say localhost, this means that this task should run on my own system instead of a remote one. So of course, let's try it in JumpServer if it works. I just put host localhost in there, but it turns out I get an error message that's saying dangerous keyword is detected, host : localhost. So I guess at least they knew about this type of attack and knew, okay, maybe we have to block something here. But also a dangerous keyword sounds a bit like there's a block list going on. Who knows? Maybe we can bypass it. And after searching through the code, of course, we find the whole list. There we have it. So I have like host localhost, host 127.0.0.1, and like some variations. So maybe you can bypass this by finding like a weird other keyword. I didn't know anything what the correct keyword was. So I just checked how they use this block list. Surely they just parse the YAML and go everything one by one and check everything. They instead not parse the YAML. They just read the whole file and do a string contains on every single line. So this means that we can do some additional tricks by using not only finding like a new keyword that bypasses the existing list, but by also abusing the flexibility of YAML parsing. Fun fact, you can put JSON in YAML. It just works. Try it. Like it works 99% of the time. There's like one or two edge cases that are really funny, but if you just paste this one in the YAML parser, it will just take it and read it as a valid YAML. What we can also do is use a nice feature of JSON, namely Unicode escapes, which is basically you put a backslash, you put a U, you put some digits, and then this thing will be read as the Unicode char point instead of the that is representing this. Sorry. For example, 00664 is a D, and I think 0063 is a C. So if we want to run this as a job, Salary will first check, okay, is there any dangerous keywords in there? And of course, there isn't, because there's something about a backslash U. I don't know what that means. Not a blacklisted thing. But if I now give this further to Ansible, it of course uses a full YAML parser, and these things will be decoded and read as what they actually mean. And so the task will still run locally. So yeah, so how does it look like? We have the same setup again. The attacker has an authenticated session. They have access to at least one host, and they create this YAML file and post it to Salary. And this will lead Salary basically to execute on its own host instead of connecting to another server. And so now we can execute anything here again and do the same thing again, like take over all the servers, read all the logs, something like this. So again, to conclude, we have compromised the entire database. We get all the credentials. We could also create like a new administrative user. I mean, because why not? Delete the logs and also compromise like other hosts that are in there, and also even like a interesting point, hosts that are added in the future, because maybe the local admin will at some point decide we need a new server and also add it to JumpServer. And if we are still in there, we can also get access to that one. So to that last point, there's of course still a slight catch. We can still go even one step further, even after doing all of this, because what happens if they just update? JumpServer is running usually on a single host system as using Docker containers. And they use Docker Compose to manage all these different containers. And at some point, maybe the admin decides, I want to download the newest update with the newest security patches, for example. And what will happen then is that our nice reverse shell is now gone because, the container is recreated and basically reset to a clean state. So if you want to really achieve full persistence, even across updates, we would have to escape a container here. But I mean, usually it's quite difficult because Docker is secure nowadays. But maybe we can still pull it off. Let's see. So it turns out they run this container Coco here as privileged. And I guess by some of you already know what this means. We can quickly check the documentation. It means that basically all security guarantees are thrown out of the window. The privileged flag means that you're not sandboxing anything anymore. This container just can get escalated to the host system. And they can do it basically by, mounting the host file system or registering like a new kernel module or like some magic with C groups that I don't understand. Relevant for us is that we can just copy paste another exploit if we get remote code execution inside the Coco container, that is. So maybe they also have some interesting functionality that we can exploit here compared or similar to Ansible that we've seen before. So, one nice thing that they offer is that they not only allow SSH, as I said, but also other languages, other protocols. So, for example, MongoDB or PostgreSQL or something like this. You can also access it via the web terminal. So here I'm using having a MongoDB shell directly in my browser, connecting to some MongoDB that is added to JumpServer. How does it look like? Because, of course, I can't usually run a MongoDB shell inside my browser. It's not implemented there. So again, they do some tunneling and proxying stuff. So the authenticated user here uses a WebSocket that goes straight to the Coco container. And they want to create like a new MongoDB shell session. So now the container will create a new subprocess of the MongoSH client, which is just the regular client that you can also use on their own laptop to connect to a MongoDB database. And this thing will connect to the database for us. And then at the end, if the connection is set up, the WebSocket is basically redirected to this subprocess. So all the output of this process is sent back to the user, and all the inputs that I put in on my keyboard are sent directly to this process. And so it's basically as if I would have installed it locally, but I can use it in my browser. It turns out MongoSH is just Node.js under the hood. So they basically just use the Node.js CLI and put some extra libraries in there that handle the connection to MongoDB databases. But this also means that we can not only use the existing MongoDB functionality, but also all the other stuff that Node.js offers. For example, just running a new shell command or something. So let's just try it. So here I have my attacker. He's authenticated and also has access to this MongoDB database with the user account. So I can just say, hey, MongoSH binary, please run this shell command. And of course it works. And again, we get root in this container. But we've seen, this also means when we actually run like an escape, Docker escape payload inside this container, because it is privileged, this will escalate to the entire host system and affect everything, all the other containers as well. So basically, you can do whatever you want, all the previous things that we had before, access all the hosts, delete the logs or something, but also getting complete persistence even across updates. And I think we should take another look at that one, yeah? So let me just go over here. So here, everything should still work. I have my virtual machine on the right side running JumpServer in the vulnerable version. On the left side, I have prepared my exploit script, and we can use the same thing again. We have here the first step of the user and their leaked, or not even leaked, but their public key, and we use that to just log in. And we get the API token again. We see that we have access to a MongoDB database, and then we can execute arbitrary commands in that container, send the Docker escape payload, and now we basically have like a sort of root shell. So, for example, I can just say, hey, what's my ID? Yeah, it's root. Okay. I can also ask, am I actually on the host system? And it turns out, yes, it's saying Ubuntu and not Cocoa anymore. So it should be this for VM on the right side. And if you still don't believe me, I have another thing set up. Yeah, I think that says everything. Okay, but let's be honest, like what happened here? Like how could such vulnerabilities crop up in this case? And it turns out the root cause here is like a gap in the threat model of JumpServer and the software that it included to offer more functionality. So because JumpServer, they are actually having an interesting threat model where they say, okay, you can execute code on a remote host that you're authorized to access, but you're not allowed to execute code on local hosts, so not inside of the Cocoa container or inside of the Celery container. But this is, of course, different than what Ansible and MongoSH believe, because they think of themselves as a local CLI application. So they are like, okay, if you can run me, you can already run anything on the system anyway. So why should we take any measures to prevent this? Even better, it's a feature that they offer subprocess running shell commands on the local system and stuff like that. So this is just a fundamental mismatch going on here. And of course, not a very easy thing to patch. But it turns out the JumpServer developers found a nice way to do it. They actually fork Ansible. So this is something, I mean, again, another fork, but it's a cool thing. So now they can use a sandbox instead of the classic Jinja 2 templating engine. And they can also disable the local connection plugin, which is used to run code on localhost instead of a remote host. So they just disabled this dangerous functionality here. And in the case of Cocoa, where they have MongoDB and also the other database CLI applications which have similar issues, they can just drop the privileges of the process that they are running to nobody and drop the environment, and that should at least mitigate the issue. Okay, what a ride. I mean, we went from not being authenticated at all to having remote code execution on the host system in the end, like in multiple different ways. We can access all the hosts that are inside the network. I think we should pack it up now. So first I want to give some shout outs to Fit2Cloud, the company behind this thing, because at least they are very responsive. They quickly fixed the issues, and very outstandingly, they fixed the Ansible bugs I reported to them 1 month ago. 1 month ago. So now I can talk to you about them. Otherwise it wouldn't work like this. Everything is disclosed publicly, and we also got some nice swag. Very cool. Also, shout-outs to the previous researchers who looked into JumpServer, like Xingyang Peng and Lauliet of Sangfor. They've found this cool password reset code fixation bug that I already mentioned, but also a path traversal in the Ansible playbook upload feature. So basically, they could combine also these two things to a full remote code execution chain. I highly recommend you reading their blog post. And also, again, Ethan Yang, Huisong, and PokerStar XY, who discovered initially the SSH plus multi-factor authentication bug, which led me down this whole path of looking into how this actually works with SSH. Okay, conclusions. I mean, we've already seen microservice architecture can lead to exposed API properties and endpoints. So what this means, what you should look out for is if authentication is taken care of by like only one component, not by the other components, and if authentication only happens for human users but not technical users. So maybe some stuff can slip through there because developers just missed to authenticate these extra properties like the remote address or the SSH public key thing. You should also analyze the assumptions that the included third-party software makes. So this, of course, means the threat model analysis that we looked at. So do they assume that code execution is okay or not? I mean, there's a big difference in the threat model of a CLI tool versus a web server. But also maybe something more subtle like the SSH plus MFA bug, where public key checking is usually assumed to be a stateless operation, but Cocoa actually did something stateful by remembering the multi-factor authentication state. So if you now analyze this, you should, as a developer, act accordingly by configuring everything in a safe way. And if that's not possible, maybe you can do their approach like fork and patch or job privileges, containerize, what have you, and at least mitigate the issues. And like, don't run privileged containers ever, please. So I think this needs no further explanation. And as a final word, to all the admins out there, when you put all eggs in one basket, it better is a very secure basket. And that's it from me. Thank you. So I think we have somebody having a microphone somewhere. Was there a question here? I'm not sure.
Quick question. So JumpServer is a Chinese company?
Mm-hmm.
Yeah. So do you trust on this architecture if it's a Chinese company? Just because I never work with a Chinese product. Just
okay.
There is something behind, like transparency on where, how you can use JumpServer to access your organization and so on. There is something?
I mean, JumpServer is an open source tool, so you can see all the code that went into making it. So you can always just download it and audit everything. I, of course, didn't look at everything, but from my eyes, it's not looking like they want to do anything weird or something. But I can't really comment further. I would say it's just I just looked at this from a code perspective and not a China or not China perspective.
So thank you very much for your talk.
Do you know why the Coco container was privileged by default?
Yeah, I also wondered, because in my opinion, it isn't that necessary to do it. They used some privileged syscalls. For example, I think it's called unshare. So where you can basically change stuff about, I think, process namespacing or something. I'm not entirely sure. And I feel like it's not entirely necessary to do it in their case, but they said, yeah, that's the reason why we add the privileged flag. And yeah, that's it, I guess.
Thank you.
So I think that. Was.
I really enjoyed it. Thanks for walking us through that. Have you, or in the past, or would you consider maybe giving this presentation to at a developer conference? Because a lot of times it's super interesting for us to hear, the latest, greatest way of breaking stuff. But some of the stuff I see on a day-to-day basis are just developers doing terrible things. And a lot of times I end up spending a lot of time in doing like user awareness, but for developers. And a lot of times showing them these cool stories and how you broke their shit. And, getting them to sort of get behind that and consider threat modeling and consider some of these secure by design principles could maybe help push, development in a better direction.
Yeah. So, the Sauna R&D team, we are regularly visiting different conferences and also sometimes developer conferences, if it makes sense. And thanks for the suggestion, definitely. I'm not sure if I will find time in the next few months, but yeah.
Yeah, thank you also for the wonderful talk. I really enjoyed it. I'm always amazed. You just look at this thing and then you click on this question mark button and you see, see here I can put some variable in there that looks interesting. So what is about the ratio of how many times you click on a button? Oh, that looks interesting, and how many times things actually work out? I mean, I try to click sometimes, but I never found something. So my ratio is like, 1 million to 0. So what is yours?
I mean, I also didn't count, but I mean, here it was really this case because because this software JumpServer is like packed full of so many different features that there was something to discover basically around every corner. This is of course not the same for like all the software that we look at. So I think this was rather exceptional for the things that I looked at in my career so far. Yeah.
Why did you look at JumpServer in the first place?
So the thing is that we at Sonar R&D, we basically check out open source software and try to find if we can find vulnerabilities and later on publish stuff about it. So basically somehow the goal was to publish this talk, you could say, in the end. And JumpServer just seemed like an interesting software to look at. So not much more to it. Another one here, I think.
Yeah, thanks, Lost. Very inspiring. In your daily work of finding vulnerabilities, how much do you leverage Sonar, and how effective is this?
Yeah, so we basically use it every time that we start a research project, and it's effective some of the time, of course not all of the time, but we always try to use the times when it didn't work out and we find something manually, but Sonar didn't find it. We always try to improve the engine afterwards and talk with the other teams in the company to actually improve the analysis. So that's something that we discovered, but the analysis didn't discover it, maybe catch next time.
Thank you for your talk. Since it's a jump box, did you hear about any company that was compromised because of this set of CVE?
Yeah, so the issue is that it's only really used in China from my knowledge. So there's always like a bit of a news gap, I would say, from like the Chinese cybersecurity world and the like European or American cybersecurity world, so to say. So I don't know of anybody who got compromised because of this, but apparently at least on some like threat intel sites, some of this made quite some rounds. So I don't know. I think that's it for today, right?
So thank you for the talk.
Yeah, thank you for listening, everyone.